Moreover, it is old.
I think it's broken in, so it's very comfortable.
Hello everyone, thank you very much for being here. So we'll just start the lecture series, the seminar today. So yesterday, Professor Kabowski told us about how structural transformation is thought about and how it's modeled. But then one thing that came out from most of the analysis yesterday was how the balanced growth path is being divorced from the structural transformation. So this paper is looking at how to incorporate these two. So let me just give the floor to Joe for today's seminar.
Thank you. Thank you for having me back after yesterday. This is joint work with Paco Buera, longtime co-author of mine, Marty Mestieri, and I think Marty, I should probably have updated. I think he's at Pompeo Fabra, and I think this should say Federal Reserve Bank of Chicago and Pompeo Fabra. And then Danny O'Connor, who was an undergraduate on this project, is now a graduate student at MIT. A very smart person. I think he'll be a well-known economist in a few years. So this paper connects with what I was talking about yesterday. I think of the central question in macro development is understanding the process of industrialization, deindustrialization, and capital accumulation along your growth path, understanding how countries industrialize and grow. Industrialization has kind of two things that you think about in industrialization. One is manufacturing industry growing relative to, say, agriculture. That's the structural transformation part. But the other is just a heavy amount of capital accumulation. And so, understanding this is a central question. As I mentioned yesterday, the existence of multiple sectors growing at different rates generically rules balanced growth path. You can get balanced growth paths back, as we discussed yesterday, but only for very knife edge assumptions. The problem with those knife edge assumptions is, as Shafat mentioned, I mentioned yesterday, is that they divorce growth from structural change. And so it's not a very satisfying analysis if the two are completely unrelated, because somehow we think they must be intimately related. So there's a technical question about how to characterize models that are non-stationary. And this stable transformation path, which is the title, is in many ways a technical contribution. I'm going to emphasize less of the technical part in this talk and more of sort of the, once we solve it, what do we get out of structural transformation models? But when you don't have a balanced growth path, well, there's two ways to look at a balanced growth path. The first is a balanced growth path is useful if we believe in Caldor stylized facts. We believe that if all these ratios are constant, then you can really buy into a balanced growth path. But the other thing that a balanced growth path is interesting is because that's where models hang out. This is where the theory tells you the economy should be hanging out. So if you're a business cycle person, you linearize around the balanced growth path because it always returns to the balanced growth path. So a model that has a balanced growth path, but only at infinity, is not, that balanced growth path is not very interesting because it's balanced, but the economy's never there. Or, during the interesting time, the economy's not there. So instead, we want to be able to characterize what we're going to call medium-term growth dynamics that are independent of initial capital. And that's what potentially time varying, doesn't have to be constant, but that's what we're going to technically characterize. So we introduced this new dynamic equilibrium concept to study medium-term. I'm not sure what happened the last week. What do I mean by medium-term? It's not going to be the short run, which has to do with transitional dynamics. like neoclassical convergence. That has to do with the initial values that you start off with for your capital stock, for example. And it's also not going to be the very long run. It's not going to be asymptotic dynamics. So we're going to live in this middle range where things don't depend on initial conditions, but they move around. They're not only asymptotic properties. This STRAP, the stable transformation path that we introduced, is going to be it's a generalization of a balanced growth path. But whereas a balanced growth path has to be, everything is constant, the STRAP is going to move around. So it's going to be stationary, but it's going to be independent of these initial conditions. And it's going to be determined by the productivity process, the vector productivity processes that the model states. Not the initial condition, but the productivity process. And then, and this is what I'll emphasize more in this paper, we apply the STRAP to a structural transformation model. This is we believe to be a much more general concept. We're going to apply it to the model that motivated it, which is structural transformation. We're going to be able to relax the knife edge assumptions that people often use and study these capital dynamics during the time of industrialization and deindustrialization. And so when we relax these conditions, we're going to have aggregate growth and structural change intimately connected. And then we're going to look quantitatively at what the predictions are. And I'm going to show you that moving away from these knife edge conditions is quantitatively important. We're going to be able to count for the non-stationary dynamics and very protracted dynamics in across development that we see in the data. And we're going to see that kind of the dominant feature in growth is going to be this Baumol's disease, which I talked about yesterday, which is moving away from agriculture, which is a fast-growing sector, to services, which is a slow-growing sector. We're going to see that growth slows down with development.
So just as a clarification, so now you are going to, so that now the quest is not to be able to match a balanced growth path. Is that?
We're going to completely abandon that.
Okay.
And maybe I ought to this is a question about rewriting the paper. We maybe ought to lead with the facts to tell you that, you know what, that's the most sensible thing to do, because when you look at the facts, I'll show you them toward the later part of the talk, that the balanced growth facts don't hold up in the data over the long, the broad development range that we're interested in. It might be a reasonable approximation for thinking about 30 years or 40 years of US growth or something. But when you start looking at really big changes in development, these things don't hold up. Okay. All right. I mentioned that this technical concept is much broader than just structural transformation. We say this just because these are like kind of well-known papers in the literature where you don't have balance, where you have a transitional medium run dynamics that you'd like to be able to characterize. There's work on unified growth theory and moving from Malthusian economies to growth economies. They have this feature. And so you can apply the STRAP to these models, and we actually do in an appendix. There is a lot of work done on investment-specific technical change. And there's a very influential paper by Karababunis and Neiman that shows that there's been a long-run decline in labor share in the data in most countries. So this is another type of model that you could characterize using the STRAP concept.
So just to be clear, so your model will also generate the features, say for instance, that Karabunis and Neiman show in the data, that your model will be able to match a decline in,
Our model, the model I present today is not going to do that. What I mean to say is this dynamic concept called a STRAP can be generated for these models to characterize these models in a way that they weren't characterized when they originally wrote the paper. the people solved only from an initial condition. You could never distinguish sort of what was driven by initial conditions and what was driven by the actual productivity processes that they were written down. So in this model, and I spent a lot of time yesterday talking about non-homothetic preferences. In the model I'm going to present to you, we don't use non-homothetic preferences, but you can use this. We actually have, again, an appendix where you can apply this concept to models with non-homothetic preferences. And one of the common features of all these models, there's some dynamics that have a non-stationary equilibrium. There's some interesting medium-term growth dynamics, and the balanced growth path exists only asymptotically. In the case of like Karabarbonis and Niemann, the balanced growth path exists when labor's not earning anything, when everything is in capital share. That's not like an interesting economy to analyze. We care about the dynamics leading up to that, which is what they solved. Okay, so I'm going to give you the given a very simple canonical structural transformation model to sort of explain why there's no balanced growth path, so you have a good sense of what the problem is. Then I'm going to introduce the concept of a stable transformation path, and then I'm going to skip this, which is and this is where Danny comes in, the smart guy in the group. The guy, as an undergrad, he was helping us prove the existence, the uniqueness of this equilibrium concept. So we'll define it, and I'll show you the stability properties, but I'll skip over the existence and uniqueness. You can trust me. Danny's a smart guy. And then I'll show you the development implications. And I want to spend most of the time actually on these development implications. But getting to this requires a little bit more understanding. Okay. So there's three sectors, just like yesterday: agriculture, manufacturing, and services. They're going to be Cobb-Douglas technologies with exactly the same exponent, parameter on the exponent, the Cobb-Douglas. They're going to have differential productivity growth. Agriculture is going to grow faster than manufacturing productivity. Manufacturing is going to grow faster than services. It's going to be elasticity of substitution less than 1. All this is exactly like I showed you yesterday, except that we're going to get rid of the non-homothetic preferences. There'll be a representative household that has a CES aggregation of their consumption from these three sectors, and constant intertemporal elasticity preferences over an aggregate consumption. And we're going to assume inelastic labor supply. And then this is a little bit of a twist on what I had done yesterday, which is we're going to take the investment goods are also a composite of value added from agriculture, manufacturing, and services. But they have a different composition than consumption goods. And investment will have differential productivity growth. I'm going to take the closed economy version of this model. And I want to say that I didn't invent, none of this is novel, other than Herendorf, Rogerson, and Valentini, their 2021 restud paper, did this in 2 sectors. We had a 3rd sector because we want to map it to the data. So there's nothing innovative about this. I'm just going to use this to illustrate what the problem is. So we do this in continuous time. Infinite discounted utility. You choose your consumption. You choose your investment. You choose your capital. And you choose your bonds. And bonds aren't going to do anything except price and interest rate that will look like what macro people are used to looking at when we come to the Euler equations. And your consumption, your expenditures on consumption, your expenditures on investment, and your purchase of bonds has to be equal to your labor income plus your capital income plus the interest you make on your bonds. There's going to be no bonds in the model. Again, this is just going to price the interest rate. And then there's a capital accumulation, standard capital accumulation equation, which is rate of change of capital is your investment minus your depreciated capital. This is what I presented yesterday. Consumption in agriculture, manufacturing, and service value added have different weights here. Sigma C is going to be the elasticity substitution. It's going to be less than 1. Note the elasticity substitution is, in general, is going to be particular to consumption aggregator. Okay? So here, you took your aggregate consumption, you solved that intertemporally. At every period of time, you're going to choose the composition of these to produce the aggregate consumption. Does that make sense to everybody? Then there's the investment sector. The investment sector comes from value added in agriculture, manufacturing, and services, which is again a CES aggregate. What's different about this one than the one I just showed you, the consumption aggregator, is that the weights on the different sectors could be different. And I mentioned that in general, investment is much more intensive in manufacturing or the industrial sector than consumption is. Then we could have potentially a different elasticity substitution here in investment than in consumption. And then we're going to have technical change that's investment specific. We're going to have investment specific technical change. And we're going to say that this grows at a rate gamma x, which is positive. So you're going to get better at producing consumption goods, investment goods, relative to consumption goods over time, which is something that we see in the data. And I've mentioned that all of these things, these parameters in this that are up here are investment specific. Consumption specific ones were last slide, and this is today's.
Sorry, when you say you see it in the data, you mean price of investment goods are falling relative to consumption?
Yeah. Though not here. Not in the data here.
Oh, really?
But in most data, Malaysia's an odd. I looked at it yesterday. I'm not sure why. That's the situation. Okay, so you have value added that's produced with a Cobb-Douglas production function. So this is for sector J. Again, the exponent's the same. AJT grows over time at a constant rate that depends on the sector. Agriculture grows faster than manufacturing, grows faster than services. And that value added can get sent to investment aggregator, it can get sent to the households for their consumption aggregator. This implies asymptotically that one sector takes over the economy. That because both these elasticities of substitution are less than one, eventually services takes over the economy. It's the slowest moving sector. So there's only going to be services. This is going to be, you're not going to understand why I'm saying this at this point in time, but just imagine as a thought experiment, if you were to take time back to negative infinity, you would get that the entire world is agricultural. Because agriculture is the fastest growing sector, that means back at negative infinity, it would have had the lowest productivity, right? So, back to, okay. So we have asymptotic balanced growth paths on both ends of this eternal world that we've created. But in the middle is what we'd like to characterize where the interesting things are happening. Okay. So here's the requirements for a balanced growth path. Come from two things. One is the two dynamic equations in a macro model. There's the law of motion for capital and the Euler equation, which is a law of motion for consumption. If we want this to be constant, like Caldor stylized facts, you can very easily see that investment over capital has to be constant. So and then what is that? Well, we can substitute in the budget constraint, which is investment is just income minus consumption expenditures. That's going to be investment expenditures. Over what I've done here is put the value of the capital stock. Why is that? Can't remember exactly why that is at the moment, but trust me on that. I'm trying to think where the PX came from. Should have slept a little bit more yesterday. But basically what it boils down to is in order to get this thing to be constant on this side, you have to have that income in terms of the investment good and consumption expenditures in terms of the investment good have to be constant.
I think you have PX here because you have values in the numerator as well. Like
What's that?
P times Y is in the numerator and PC times C. So you need PX down so that, because in the, you're moving to values overall.
Oh, yeah, because this is, yes, exactly right. This is, is going to equal PX times X.
Yeah.
That's exactly right. Yeah, thank you. Good catch. Okay, so that's the first equation. It tells you that you're going to need output and consumption expenditures to grow at the same rate as capital when translated into the units of the investment good. Okay, so the investment good price is going to be very important. Usually in a model with just a single sector, that investment good price is the same. It's a constant price. It's consumption's the numeraire, investment's the same. Here we have different goods. Now you have the Euler equation. The Euler equation is that the growth rate of consumption, I did everything in discrete time yesterday. This is continuous time, but they're analogous. The growth rate of consumption is the interest rate minus the discount factor, and here's the intertemporal elasticity. When we substitute in for what that equals, the interest rate, there's the extra terms here. This is the interest rate, this is the rental rate, minus depreciation. In a single sector model, that's the interest rate. But here, it's normalized by the price of the investment good. And the second thing here is that we have the growth rate of the relative price of investment shows up. Because if I save, I have an investment good tomorrow, and the value of that depends on, I give up consumption and I get an investment good. And so the growth rate of that, the rate of change of the relative price is like a capital gain on that investment. And so it shows up in the Euler equation. So what people typically do is they define consumption expenditures normalized by the price of the investment good, because that's what you need to be constant. So you do this change of variables, and this is what you get. Now, if I want this to be constant, I can see what needs to be constant. I need the rental rate in units of the investment good to be constant. That's the first thing. And the second thing I need, generally, is I either need log preferences, which is what EAPCE assumed, or I need that the relative price of investment, the growth rate of the relative price of investment is constant. Okay? So the next couple slides are going to show you that in general, a structural transformation model, if I don't make this log intertemporal preferences assumption, this relative price of investment is not going to grow at a constant rate because of structural transformation. And the other thing is that this rental rate in units of the investment good is also not going to remain constant. Okay? So this is the heart of the problem. And just to show you, this is the relative price of investment. Now, this grows at a constant rate, investment-specific technical change. But what's happening, this is kind of coming out of the structural transformation in the investment sector and the structural transformation in the consumption sector, which are different. They have different weights in them. They have different potential, different elasticities of substitution. So it would take a miracle for that to remain constant. And it doesn't in general remain constant because we have this biased productivity. So agriculture is growing at a faster rate than manufacturing, and agriculture is much more important in consumption than it is in investment. Services are growing at a slower rate. Services is much more important in consumption than it is in investment. Manufacturing is the opposite. It's more important in investment. Does that make sense? Okay. So in general, that's the relative price of investment is going to be moving around. The second thing is, what's the rental rate in units of the investment good? Well, here you see the price of investment showing up again, and you already sort of showed that that's going to be moving around in a weird way because of structural transformation. So you can solve that, you get this aggregate production function, but this script X is again driven by structural transformation. Okay? So neither of those are generally going to hold. And what they're going to do, to give you an intuition, is in your investment dynamics are going to be the amount of capital that you'd like is going to be changing over time because the relative price of investment is going to be changing over time. And the return on capital is going to be changing over time. So the capital dynamics, if I start from an initial condition with a balanced growth path, I start from an initial condition and I move toward the balanced growth path. In a world with the strap, this isn't constant anymore. I'm moving toward a moving target. And so I'm always adjusting things because the target itself is moving as the relative price of capital and the rental rate of capital changes over time. Okay? That's kind of the intuition on why this becomes a very complicated, dynamic thing to characterize. All right. So let me give you quickly, again, I'm not sure how many people are macro people, but we typically define competitive equilibria. And a competitive equilibrium starts with an initial level of capital, initial technology levels, and you solve for the series, right, of prices and quantities that satisfy the maximizing conditions and the budget constraint. And then there's a couple other conditions. One is I mentioned that these bonds are just in there to price things, so we say that those have to equal zero. You solve your optimality conditions. And then there's this transversality condition, that the value of the capital stock asymptotically goes to zero.
Can this non-macro person ask a question about the strap modeling?
Okay.
It seems that there is asymptotically, it seems that service will converge to just service industry for all these economies. And I'm just wondering, does that then we depart from the closed economy and go into the open economy? Because just trying to reconcile the preference story about how there's still necessity for agriculture and other industries, then having an open economy kind of allows you to have this convergence into services.
So here's what happens. You never get rid of agriculture, nor do you ever get rid of manufacturing. You become so productive at agriculture and manufacturing that you have tons of agriculture and tons of manufacturing, but you're able to produce it with very little resources because you're so productive as time goes to infinity. And so the prices on these things become negligible. And so you have a ton of agriculture and a ton of manufacturing. You have a ton of everything as time goes to infinity because you've gotten really productive. But all of your resources, one person can do all the manufacturing. One person does all the agriculture. And so the economy is effectively, everybody else is in services. That's how this works. Yeah. And I mean, going back to infinity, negative infinity, it's not that everybody's in agriculture, but overwhelmingly, almost all the resources in the economy are used to produce food in very low-income economies. Okay.
So, sorry.
Yeah, go ahead.
Were you finished answering, or?
I was going to just say that the balanced growth path, it automatically satisfies the transversality condition. So, go ahead.
No, so I just wanted to ask, so I know the price of investment good is falling because of the technical change, you're getting better at it. And so the rental dynamics, they respond to the stock of capital, right? The rental rate dynamics. Yeah. And it's basically, you said something about PX and rental rate moving differently, yeah. But in the end, rental rate is just a function of your stock of capital, which is a function of your prices, right? So is there a way to simplify that, or?
Let's see here. The rental rate in this economy is, because you can get an aggregate thing because this is one of the reasons we choose to have alpha be the same in every sector. you get this aggregate production function. This is fine as long as capital is going at a constant rate. What you need is for this, because this is negative, right? Power is negative. You need for this to go at a constant rate to balance out capital accumulation. And in a normal model, productivity growth is constant. But in this model, productivity growth in producing investment is driven not only by the investment-specific technical change, but the structural transformation that's happening. Because these different sectors are growing at different rates. As you move from one to the other, you have kind of like a Baumol's disease thing happening in there as well. Okay.
And the rate of change of AXT, the technical the IST shock, the investment-specific shock, that's the growth rate there is constant as well, is that, or?
Sorry, I missed it.
The growth rate of the investment-specific technical change, that would be constant?
That's constant.
Okay.
That's right. But that other term is not.
Right.
Yeah, that's the problem. Okay, we do some things to characterize this. One is we kind of, let's see. I want to kind of show you two things, and maybe I should skip over this, but one is we can solve some special cases analytically. We can solve it for alpha equals theta. I'm not sure why, but the math works out when alpha equals theta. And then we can linearize around the balanced growth path, just to show you the dynamics. All I want to say for the first case is just that the capital dynamics, capital accumulation dynamics are very quick relative to the structural transformation dynamics. Capital, like a half-life of initial level of capital disappearing is the same as it is in the classical growth model, something like 15 years. But the structural transformation dynamics are going to go over the course of a century, in the same way that they do in the data, because this is the model that's used to sort of match the data. So this is just about eigenvalues and characterizing things. This is when alpha equals theta, this is just kind of showing what happens. This is capital as a function of time and as a function of the initial level of capital. So you have this first term, which depends on the initial level of capital. Okay. That's going to go to zero. The initial conditions are going to disappear. You have this second term, this K star, which is really the strap. And that's going to be something that moves around. That's going to be this moving target that people are going to be following with the capital stock. In a balanced growth path, you'd get the exact same thing, except this would be constant. And what we let is this vary by time. Okay? And so we're going to call this the strap. Let me give you this example. Let me see, does this move? No, it doesn't. In a typical model, you have, I'm getting too into the weeds. There's a third dimension here, which is productivity or time, that you can, usually like a balanced growth path is a single point that the economy moves to in this, which is consumption capital space. Here, you start, this is the agrarian balanced growth path. This is the service balanced growth path. And you move from here to here over time. That's the dynamics. And this is kind of trying to show you this third dimension. You can imagine this capital stock being Germany 1950. They have too little capital given their productivity. And so they're going to accumulate capital, and their expenditures are going to grow over this, follow this path. You can imagine that exact same capital stock for Germany in 1700, and that would be the same capital stock, but now it would be above the strap. And what you would do is you would eat a lot of your capital stock because it's more than you'd want, and your capital stock would decline for a while and then go on the strap. Okay? So there's this third dimension of time or productivity in this because it's a moving target. Okay, so we define it. I would say the big thing is that you have two differential equations, you need two conditions to pin that down. Usually we use an initial capital stock and an asymptotic transversality condition. We get rid of the initial capital stock and we say we're going to use the balanced growth path at negative infinity and positive infinity, because we know what those are analytically. So we solve. Okay. We prove it. Then we're going to calibrate this to the US post-war period, just to give you a sense of what these look like, what the growth implications are. So now I'll show you the implications. I'm going to show you that moving away from the knife edge assumptions is important. If we move away from theta equals 1 and put the value that we really think, like theta equals 2, that's what we usually put in the model, we're going to find that the direction of the investment rate, how the investment rate changes over time, qualitatively changes the actual movement, the direction. And if we say that investment is only consists of manufacturing goods, which is the other assumption that EAPCE do, they're going to get a decline in aggregate growth. We're going to get, they're going to get an increase in aggregate growth. We're going to get a decline. So these things matter qualitatively. And then I'll show you some cross-country data, which is a development pattern. Okay. So this is a picture of what you get. This is calibrated in the United States, 1750. You get counterfactually, that the entire economy is, in 1700 is agricultural, although it's not that crazy. Most people are in agriculture in 1700. So you get this decline in agriculture that kind of matches the pictures we saw. You get this increase in services, and you get this hump shape in manufacturing. And I mentioned that the hump shape in manufacturing is not something that models that don't have investment and structural transformation investment can match.
But the timing, does it also match? Like you can see here, the hump is already for manufacturing in the 1900s in...
Yeah, it's not perfect. This looks like at about 1925, manufacturing starts declining as a share. It's really more like 1950 and 1960 that it declines. Although, obviously the real world has World War II and all sorts of other things that you might think, and open economy and all sorts of stuff that might have adjusted it. So it's not horribly off, but it's certainly not on. But the quantitative magnitude is of reasonable, it's a reasonable, and so. Now, structural transformations occurring, broadly consistent, in a way broadly consistent with the data. Growth, we now have growth implications, which is, well, let me go to the investment. The investment rate rises with development. And that, you can see as the investment rate rises, it coincides with manufacturing sector increasing because investment's very intensive in manufacturing. Eventually, that investment rate stays high and manufacturing falls, and that's because the relative price of manufacturing goes down because you become more and more productive at producing and manufacturing. But the initial rise is coming from this rising investment rate. Okay? Now you have two things happening. You have Baumol's disease, which is you're moving from fast-growing agriculture to slow-growing services. But you also have the investment rate increasing over time. So one of those is going to make growth slow down. The other is going to make growth increase over time. And quantitatively, the Baumol's disease wins the battle. And so we see growth slowing down over time. It's not great. I'll come back to this. We don't think that the economies were growing at 8% in 1700. So there's some wins and some losses in this curve, but we're able at least to characterize what the model we've written down implies. Okay. Let's see. I want to show you, you could do this. I can connect this investment rate to the relative price of capital and the rental rate on capital. I'll skip that another time. But I want to now consider alternative models. So these different parameterizations that have been used in the literature, these knife edge assumptions, and show you that they matter from our benchmark. So the benchmark is in black. The theta equals 1, the log preferences, log intertemporal preferences, is the blue. The idea that all of investment is done in the industrial sector is the green. And the idea that there might be a mix of goods going into the investment sector, but there's no structural transformation. It's always the same share. That's going to be the red. And obviously, the first thing you can see is that if you say all investment is in manufacturing, you get a level increase in manufacturing because all those investment goods are made out of manufacturing. So it has some implications for the structural transformation. It has to come out of somewhere. It comes out of the agricultural share early on because you have investment going in. Okay, so this is, it matters for the structural transformation. That's not that interesting to me. What I want to emphasize is what it matters for the growth. So this is the one where they say that, Guy and Pissaridi say that all investment is made out of, is produced in the industrial sector. They get that the chain-weighted growth the way that we measure it, should be increasing over time. Our model is going to predict that growth declines over time. Okay, so this is a qualitative difference of going beyond these knife-edge cases. The investment rate, if you say that, this is another Guy and Pissaridi's assumption. By the way, I love the Guy and Pissaridi's paper. I mean, we couldn't make these comparisons if we weren't for Guy and Pissaridi's paper, but I want to point out the difference between what we've done and what they've done. The investment rate in their model, when you make this assumption of theta equals 1, pretty flat, but it actually declines. And our parameterization is going to argue that the investment rate ought to be increasing over time. So again, it's not just quantitatively, but a qualitative difference. And then the interest rate is, there's dynamics in the interest rate involved as well. Okay, so, oh my goodness, are you kidding me? Okay. I don't know how it showed up there. First thing I'm going to do, as I mentioned, go back to 1700. The model doesn't look too great. I want to go back, I want to look at historical data that Madison produced. I want to look at all the countries that were sort of early developers, early industrializers. Any country that reached the UK's value of income in the year 1800 by the year 1900. Take those sets of countries and plot them out for you. And this is what you get for the 10-year growth rate. 10-year annual growth rates averaged over 10 years. This is the 75th percentile, this is the 25th percentile, and this is like a nonlinear fit. And you get the growth rates increase over time, which is counterfactual to the model's predictions, which says that growth rates ought to be decreasing over time.
In fact, matches what the other person's but the one you were showing, which qualitatively was increasing over time.
Yeah, so maybe. Could tell you about something about the parameters. We're going to say we know those parameters pretty well. What we think this is telling us is something about the production process, which was in the year 1700, it wasn't true that agriculture was much faster growing than manufacturing or service productivity. And in fact, the idea that those productivity processes are constant is probably also not true. So because the strap doesn't depend on initial conditions, it doesn't matter that I have no data about capital stocks back then, because the capital stock disappears very quickly. So all of the growth dynamics are going to come out of the productivity process, and it's going to tell you that if we're thinking about these historical countries, we've used the wrong technology process to characterize growth. We probably have to go more to something like Hansen and Prescott or Galore, where productivity itself takes off, and maybe differently in the different sectors. Okay. That's one thing that we can do useful. But this, I'm saying this model is, we shouldn't be throwing out. Because the next question is, well, what about countries today where agriculture does grow faster productivity? How does a model do at matching data from the past 50 years, from the Penn World Tables, across a broad array of different development levels? So we go to the Penn World Tables data, and I plot. These pictures were made before, I don't know, Paco made this picture, which I like, with the cloud of data that's just faint. But I didn't want it to be so messy, so I just got rid of the data. I just put this 25 and 50th bound. And this is a linear fit to that. And here is the model that does the strap, the medium-term dynamics. And you see that the medium-term dynamics show a Baumol's disease, a slowdown in growth. That's not too far away from what we see in the data, the black line to the diamonds. Okay?
This is now like a cross-sectional fit, basically, of the data.
It's panel data.
It is now, okay.
So take all the countries that we have for all the data from 1950 to whatever, and plot them all by their real income per capita, log real income per capita. That's what the data is. So the black lines are the data, the bands 25th and the 75th, and the linear fit of the mean. Okay, now I want to compare it to what you would learn in the, not everybody apparently, but in the first year sequence of the neoclassical growth model. If we think that the difference between Uganda in 1950 and the United States is just that they start off with less capital, this transitional dynamics. I'm going to solve a neoclassical growth model, and I'm going to solve the strap. The strap only has medium-term dynamics. The neoclassical growth model only has transitional dynamics. And the transitional dynamics is going to say, yeah, you should grow really fast initially, but that ought to die out right away because the transitional dynamics don't last that long. Okay? So this is over, a few years, your growth rate ought to stabilize and then remain constant. But that's not what you see in the data. Okay? So then one of the things about Kaldor stylized facts is the idea that growth rates are constant over time does not hold in development. They're declining, and they're declining at a pretty large rate. You're going from 2.5% to 1.5%. So 40% of growth disappears over the course of development. And the structural transformation model, the medium-term dynamics of the structural transformation model that we characterized predicts that. Okay. Next, let's think about the capital accumulation stuff. Remember, there's Baumol's disease, which is dominating, but there's also this prediction that the capital stock ought to be increasing, investment rates, et cetera. This is capital accumulation in the data and in the medium-term dynamics of the model, and they line up fairly well. By the way, all of this is out of sample. I haven't calibrated to anything. I just took the US model, and then I should say the level is calibrated. But the trend, that's all out of sample. Here's the dynamics. This is the dynamics we know about capital accumulation, which is, of course, if you start with a low level of physical capital, it increases, but it increases very quickly, and then it stays flat. This is the investment rate. We know that the nominal investment rates are relatively flat, but they are increasing somewhat. And the medium-term dynamics, again, not calibrated or anything, are basically directly on top of the data.
So what's the difference between neoclassical and strap is that
The neoclassical
basically your
growth model has no structural transformation in it.
right. So that's
And we let it run from an initial condition. And the initial condition is average capital to output ratios at log income of 7, which is about $1,000. So we're really looking over the broad development patterns of poor countries and rich countries.
so basically the low capital puts an upward pressure on investment rate, but then as the economy moves away towards services, that puts is that the one pushing it down, the investment rate?
You mean this thing falling?
No. So the gap between neoclassical and red line. So we know why capital would increase if you start with low capital.
Yeah.
But the thing that's creating this gap between these two is that you're moving more towards services. Is that the thing? And that's putting a downward pressure on investment capital output ratio?
In this case, in the neoclassical growth model, you start with a low level of capital and you say, I'm way behind. In fact, the interest rate on capital is super high. So I want to invest a ton to catch up because the capital stock is where I'm way behind. Remember, in this structural transformation model, your target capital stock is it's a moving target. So you're not that far behind. Well, we don't even have an initial value. So we're just saying, imagine you didn't even start that far behind. Because it's a moving target, you want your capital output ratio to increase over time. Because there's structural transformation that's changing the relative price of capital. There's, here's the relative, where's the relative price of capital? Here's the relative price of capital. The relative price of capital is falling over time. It's getting cheaper and cheaper, which means you want more and more of that capital. And again, it's getting cheaper and cheaper, like it does in the data. And again, this isn't calibrated to the Penn World Table's data. This is calibrated to the US experience from 1950 to 2000. And I'm extrapolating the US to a ton of different countries, including very, very poor countries. And it lines up pretty well. Whereas the stuff that we usually do, the transitional dynamics, are very short-lived, and they go way out of what we observe, at least in the middle 50% of the sample, in terms of the investment rates, in terms of the interest rates, et cetera. But these all sort of line up very well. So the capital dynamics is lining up pretty well. The growth, which includes both the capital dynamics and the Baumol's disease, is lining up pretty well. Both of those are coming out of the predictions that come from structural transformation. Okay. Now the question is, what about the structural transformation? That's in the background, kind of driving all this stuff. And this one shouldn't be such a surprise, but it lines up fairly well with the data. The empty circles are the data, and the dark lines are the dark points are the model. So this is agriculture, services, and industry. Okay, now I mentioned one thing useful you can do with the strap is to learn about productivity processes when you don't have data on capital. So we did that historical example. Another thing that you can do is decompose growth. You can decompose growth into what comes from structural transformation, the medium-term dynamics, what comes from initial values. And so I want to do this comparing the US and Thailand post-1950. In the US, if you look at the data for those 50 years, close to 70 years, you look at the strap and you look at the competitive equilibrium that starts from the initial capital stock. They all predict 1.6% growth rate per year, which is consistent with the United States being on the strap, that the capital stock, any transitional dynamics are gone. And, but if you look at Thailand, you see 3.6% annual growth over that period, much higher than the US. Some of that is predicted by the strap because Thailand is much more agrarian, so it's faster growing. So you get an extra 0.5% that comes from pure structural transformation. And then on top of that, you get about 0.3% that comes from Thailand starting out with a low capital stock, the transitional dynamics. Okay? 2.4 is still less than 3.6. Say that 1.2% would have to come from someplace else. And in the context of the model, what you have to do is say the underlying productivity growth is faster in Thailand. So there's these three forces that are all at play in understanding the Thai data, and you can decompose which part comes from which. In Thailand, the model predicts a 12% drop in the share of agriculture and only a 2% drop in the US, which is why you get much higher growth rates in Thailand than in the United States. Because even in 1950, there's very little in agriculture in the United States. So even though productivity growth is fast in agriculture, it's such a small part of the economy that it doesn't contribute to the aggregate. Okay, I got 4 minutes. which is good. Because I want to do the second example, which may be of more interest to you. Thailand's of interest to me. I spent a lot of time in Thailand. But Malaysia, we don't have as long a time series for Malaysia. We have only from 1970 on. But from 1970 on, in the data, it grows, real GDP grows at a 3.9%, even faster than Thailand. Things aren't so great with this. The strap says 1.7%. Growth should be at 1.7%, so just a little bit more than in the US. Remember, the US was 1.6%. So we're not getting a ton of action. The strap's not predicting a ton of action. And the competitive equilibrium, the fact that there's a low level of capital, you get faster growth. So now the transition matters a lot more, because that initial capital stock is explaining a lot more extra growth than the strap. In the data, you see 2 percentage points higher capital accumulation. Remember, growth should be slowing down. So if we look from 1970 to 1980, capital accumulation is 2% higher in the data. In the model, we actually can even overpredict it, but we see that the capital accumulation should be 2.5 percentage points higher, okay? So again, what it's saying is that the transition, the structural transformation, and the high productivity are all important, although the structural transformation is much less important in Malaysia than in Thailand. So there's a question of why.
And do you have a, that's what you're going to get into as to why that could be the case, yeah?
Yeah. Do I go till noon, or can I have 5 minutes more?
Yeah. We can have 5 minutes more, yeah.
Okay, sure. So the agricultural fit for Malaysia is very poor. Malaysia looks unusual in many ways now when I'm looking at the data. If you remember from yesterday, Malaysia's agricultural share of GDP is very high for its level of income. What the model wants to say is that in 1970, given Malaysia's level of income, when we start having data, there shouldn't be a ton of resources in agriculture. And so there's not a lot of area, there's not a lot of room for additional growth coming out of agriculture, which is why this is not much higher than the US. And it should rapidly move out. In the data, there's a 24% drop in the share of agriculture between 1970 and I think about 2015 is what we're looking
In value-added terms.
24 percentage point drop, yeah. In the model, you predict only a 4 percentage point drop in agricultural share because you're starting from a much lower level. So again, the strat predicts very little extra output growth in the first 10 years and extra output growth in general. If you recall again from yesterday, Malaysia had high relative productivity in agriculture, but not high relative productivity compared to industry. So if people move out of agriculture into industry, that's going to, because of this wedge, it's not in the model, it's in the data, you get a lot of extra output because you're moving people out of the low productivity sector into the high productivity sector. So this 24 percentage point drop could explain some of this big, this really fast growth in Malaysia during this time. So you get a lot of extra output growth. Okay. Let me show you the figures. The model doesn't do too bad for hitting the K over Y in Malaysia. It starts here and ends here. So it's kind of roughly starting and ending. You look at the long run trend, it's not so crazy. A lot of movement, of course, fluctuations. Partly that's got to have the financial crisis in it and other things. So that looks pretty, that's not too bad. But with the growth, it's way off. So this is the data. Now I've gotten rid of the neoclassical comparison. The same symbol is being used to plot Malaysian data. Was I saying Thai before? I meant Malaysian. So yeah, Malaysian data. So Malaysian data is very much an outlier in terms of, and we know that, right? It's a miracle economy. But early on, it grows at a very rapid rate. Structural transformation is going to say that growth ought to slow down, but slowly. This, the strap is going to say, but what you see is a much more rapid slowdown in growth over the course of development in Malaysia. And I think that part of that, I'm going to conjecture that part of that is because of this very rapid drop in agricultural share and this wedge. There's no wedges in this canonical model, but this wedge, which I'll talk about this afternoon, called the agricultural productivity puzzle, which is that agriculture, subsistence agriculture, is very low productivity. And in many developing countries, a lot of people are engaged in that. And so you move people away from that into industrial jobs where they have a higher marginal product, and you get a lot more output. You can't do that forever. You can only do that while you have people in agriculture. And so that starts out very high and declines quickly. That's kind of what my loose interpretation of the data would be. You guys know more about Malaysia than me. Kind of everything that I'm doing with this paper and in the other two lectures is giving you an understanding of some sort of like a diagnostic process of how to come at the data. And then when you see a pattern, if you have more local knowledge, you might say, oh, this is pointing to where something unusual in the economy might be happening, potentially something problematic or not problematic. Maybe it has to do with mining, and that's not a problem, that you have oil resources, for example. All right. Connecting with other lectures very quickly. The strap, this paper, has helped us understand structural transformation patterns that we talked about yesterday. In particular, we can get the investment hump shape to be quantitatively important. The fact that these dynamics play such an important role in matching investment tells me that the models that don't have dynamics might be misestimating the parameters the real parameters, because they're trying to fit the data by leaving out a key part of the process. I've presented to you new development patterns. The takeaway message is that Kaldor stylized facts don't hold over broad development. In particular, K over Y is not constant, it rises, interest rates falls, the relative price from investment falls, and growth slows over development. And then lastly, this dynamic structural transformation model that we're able to solve sort of reframes our understanding of growth. Growth and structural transformation are intimately related. The Baumol's disease is a stronger force, that's why we get the slowdown, than the accumulation of capital. The initial capital convergence, stuff that we usually focus on, transition stuff happens very quickly. Structural transformation movements, the medium-term movements happen much more slowly and in ways that are more consistent with the patterns we see in the data. So that's it. Thank you guys for coming.
Thank you very much for the presentation. Let me move to the online participants if they have any questions on YouTube or on the WebEx.
They've all gone to lunch.
A good long nap has been had.
So I guess we'll end here. We'll have lunch outside the office space right now. I mean, I think we'll start in around 10 minutes, but then feel free to hang out and interact. Thanks a lot.
Thank you.